Cepat cepat weh, cepat. Cepat. Cepat dah lambat ni. Tunggu aku.
Hi, you have been late for class. But never mind, let us start the class. So, my name is Jason, and this is teacher
Paris.
and this is...
Teacher Chicken.
Oh, nice.
Hi guys, I'm Mayo Sensei.
Sensei.
Hey guys, I'm Teacher Zame.
And we are all the teacher for this chapter, the discrete time system. So let us begin the chapter. So in this discrete time system chapter, we're gonna include so many new things. For example, the system. But let us introduce what is it about. So in the 1930, we have the technology that just started. We have the radar system. You see the radar is so big, right? Radar, and radar is used for the fight in the World War I. They use it to prevent the enemy. They use it to detect whether there is the flight over there, so that it can prevent the bombs and stuff to save the people's life. It's quite tragedy over there. And then until 1950 to 1970, they are the industrial revolution that has happened throughout the years. And there goes our very first digital television. You see that, right? The screen there, that's actually the sign, it's called digital. And then followed by the cooler. There's a guy called Cooler there. They created a technology called FFT, the fast Fourier transform, which is the most sophisticated technology has been invented that changes the way we live in this century. That's why we can see that the satellite have sent the information. They get to use the satellite in that years. And however, when years go by, they start figuring out new technologies, and until the 21st century, we have our smartphone, our gadgets, our laptops, our mobile phones and tablets everywhere. But those things have to be connected, so that's why they were internet. That's why they were internet. They come together, and then there we go, the technology. So now let's just start with the system. System is actually like a factory whereby there are materials going inside. They will process out like a product, like our smartphone. But in this, we're gonna process out the discrete signal over there, and we come out with a new product. And we're gonna cover up all the below the details over there, the subtopics in this chapter. So why not? We just started now.
Hi everyone. So I will be covering for linearity, and it is one of the characteristics for discrete time system, and it is for consistent output. And to make it happen, you need to obey this convolution principle. So as you can see from this first example, yn is equal to sn squared. So we have two steps. So the first step is we need to group it first and multiply it. And for the second step, we need to add it individually. Is it? So as you can see from the output for part A and part B, the function is different. So it is not linear. So for the second example is yn plus 2xn minus 1. So like I said before, for part A, we need to multiply it, or this one is addition, like in group. So we take in group and split it to x1 and x2. And as we expand, we're gonna get this equation. And for B, we need to make it individually. So we have to get x1, 2x1, x2 and 2x2, and expand it, we got the same. So if we compare between part A and part B, we're gonna get A, ya is to yb, so it is linear. So I'm gonna have to proceed to my friend.
Okay guys, I'm going to talk about time invariant now. So essentially, what time invariant means is the result of the system is the same whether you put the delay at the input or at the output. Okay, to further your understanding, we're going to do some exercises. Okay, here you have y1n, alright? Okay, first we're going to put the delay at the input. Okay, how you're going to do this is, you minus everything inside the input bracket with nd. So you will get n minus nd, while over here you get n minus 2 minus nd. Okay, if you want to put a delay at the output, we replace everything, we replace the n with n minus nd. So as you can see here, we replace only the n with n minus nd. And these two equations are the same. Therefore, they are time invariant. Okay, as for the second example, we have y2n. Okay, we do it the same as the first example. For the input, we minus everything with nd, as you can see here. And as for yb, for the output, we replace the n with n minus nd. And as you can see, both of these systems are not the same. Therefore, they are not time invariant. So that's all for me. Thank you very much.
Now let's move to causality. Okay. A causal system is where the function of time consists of only either current values, which is xn, or past value, n minus k. While a non-causal system is whenever it has a function of time where the future values is considered as non-causal. Okay. Let's take an example. First example is xn plus 2xn minus 1 plus 2xn minus 2. Where this function of time, all of it consists only of current and past value. So this example is causal system. While example 2, this is current values. While this one is not n plus 1, but this is not considered as a function of time. So this is not the future values, thus the system is causal. While the last example, xn plus 2x3 minus n, where this is minus n plus 3, where the system is non-causal because it consists of future values.
Hi, okay, for stability we have two factors, BIBO and yn or Sn is less than infinity.
Teacher, can I ask what is BIBO?
Oh, BIBO is bounded input to the system, we produce bounded output. Okay, now we can see the example. Okay, for test 1 2010, we can see that system yn, un, 2un minus 2. The question asks, is it the system is stable? Okay, first, if we want to make it clear, we can see that in past system, we can produce like this, and then this system is stable because yn is less than infinity and it is finite, and the value of n is not infinity. Okay, now we can see final exam 2010 and 2011. Okay, Sn and process yn. The question is asked, is it hash n is stable or not? We can see it is stable because hash n is finite. Thank you.
Hi, I'm back again. It's teacher Jason over here, and I'm going to talk about the memory system in the topic. So, what is called memory? A memory for a system is that it has the past value, and also it has the future value. Yeah. What do you mean by the past and future value? It means that in the system we know about the past value and we also know the future value. But how about the memoryless? Memoryless, which means that it doesn't have all of this. It only stands alone. It's the only guy over here, which means it's n. Oh, sorry, it's n. It's current. So it's very lonely. It only know the current value. That's it. It's called a memoryless system. And I believe all of the topics that the teachers have taught you has totally summing up this chapter, the discrete time system. And I believe you already mastered and how this system works, right? So at the end, good luck to your final exam, and once again, thank you for watching. Goodbye.